Hello everyone, I'm Trinh, Senior Application Engineer for Valin Corporation. Today I will illustrate how to connect to the Oriental Motor EtherCAT drive model AZD-KED from a PLC. This just happened to be an Omron NX series PLC, but it can be any PLC, Allen Bradley, Siemens, Mitsubishi, any PLC that has the EtherCAT master. All right, having said that, what do we have in front of us? Here is the Oriental motor here, and it has a cable connecting the back here, and this cable basically allows to provide the 24 volt power to it or 48 volt DC. Also, the encoder feedback that connected into the ports right here. So you see a grayish connector here. That's for the encoder signal. And then coming out of this black cable, you see there are two more wires here, and that's for the 24 volt DC or a 24 volt DC that connected to this connector and to the connector here. Now, let's talk about a little bit about the EtherCAT drive, what's in there. So let me go to this PDF here. So what you see here is this is again, the model AZD-KED. That's the AZ series EtherCAT compatible driver. And the communications basically is EtherCAT field network. This also support the battery-free absolute mechanical sensor motor. That's what the motor that we use. And that's where you see the connector that I showed before. But for the drive itself, to set it up, there are rotary switch here that allows you to set up the node address for the EtherCAT drive, and that can be anywhere from 1 to 63. So that's the node address. Here is the connector that you apply 24 volt DC or 48 volt DC, and that's for this connector as well. On this connector, there are some over travel switches that you can connect. Right now, we just shorted for our demo, which is here. So you don't see it here, but we have 3 different jumper here. Okay. Now, this connector here is basically the encoder connector that allows you to connect the encoder cable, which is coming from this motor here. So that the other side is basically a gray connector here, and that's what connected to this port here. The drive itself has EtherCAT input and EtherCAT output. So from the PLC, basically you see this gray connector, the grayish cable here, that's RJ45, and that's connecting to the EtherCAT import here. The other side is basically connect to the PLC. And once again, this just happened to be an Omron NX PLC, but it can be any PLC manufacturer that support the EtherCAT master. It can be Allen Bradley PLC, it can be Mitsubishi, it can be Siemens, and so forth. Okay, so that's a little bit about the EtherCAT drive. Oh, by the way, this is DIN rail mountable as well, which is great. Make it easy to install. Let's talk a little bit about the motor itself. So here's the motor. This is the model of the Oriental motor that we use in this demo here. Okay, it is an AZM66AKH. It's a 2.36 inch, 60 millimeter AZ series stepper motor with the absolute mechanical encoder. So anyway, it comes with the absolute mechanical sensor encoder, so you know exactly where it's at. Very nice package. So that's for the alpha step hybrid step servo that Oriental motor has that we use in this demo. So let's get back to the demo here. What you see is basically a video feedback. Let me show you the program itself. So first and foremost, since it's an EtherCAT drive, so you need to get an EtherCAT drive, which is the ESI file, and we can support and get you that file for you. But here's the what I have in front of me here is basically an Omron Sysmac Studio software that I'm using to basically showcase how the motion controls PLC open function block works. And like I just mentioned, because it's a EtherCAT drive and any PLC manufacturer that support the motion control PLC open function blocks will work just fine. So you need to get the ESI file first. And then what you do is you click on here and you right mouse click and you click display ESI library. So here I already installed them. And it's down here, Oriental Motor right here, AZD-KED. Now, if you have not installed it, you need to install it, okay? And to do that, you basically, let me do it again. You go display ESI library. Right now I'm online. That's why you don't see this. Let me go offline real quick. So when you offline, you right mouse click the EtherCAT master, you click display ESI library. So now there's a couple more buttons here. You can go to the folder that you have the ESI file, which we can email you. Once you go there, let me go there real quick. Oh, I need administrator, but anyway. So you go to that install folder, you select the file, and then you click install file. And that will install that Oriental Motor EtherCAT drive into this library. Once you install it, you need to close out Sysmac Studio software and then reopen it so that it will show up down here. Okay? So that's the procedure how to install the library file, the ESI file. So when you have that, you would click the drive on this side, which is here. You select stepper driver and then you select AZD-KED and then you drag it over. I'm not going to do that because I already installed it. And once you drag it over, you want to double click on this. It will show you the PDO mapping and so forth. Okay. Once you have that, you go to the motion control setup, click on the axis here, and you right mouse click, and then you add a motor control axis. I'm not going to do that because I already add this one here. All right. I'm going to double click and show you more. So in here, you need to select the axis type to be servo axis. Before it wasn't anything. So you need to select that and then you select the axis used is use axis. And then control function, you need to select this as well as single axis position control only. And then once you have that, select the output device. You need to click this arrow down key and select that one as well, which is AZD-KED. Then you go to detail setting, and this is where you need to select the control word to match the device and the process data, right? You need to, anything that you see an address, you need to click the arrow down and select them correctly, all right? Like this one is a control word. You select the drive itself, and then here you arrow down and you select the control word as well, which is that. Same thing for the target position. Okay, you do the same thing for that. And then the mode of operation, you need to specify that. You need to select that as well. So those, at the minimum, you need those three. Then you go to the input drive. You expand that. And at the minimum, you need to have the status word and position actual values. Once again, anytime you see an address, you need to specify it. So once you've done that, you go up here and select the project and rebuild. And that way it goes and compile everything and set it up for you. So I let it finish that. And what we're going to do next is we're going to go into the program and set it up. I already set up the program already, but just real quickly, This first function block is basically for turn on the servo, which is the MC power. This function block is for jogging the motor back and forth. It's called MC move velocity. And you notice I have a jog function block here, jog FB. This function block is for move relative, meaning incremental move wherever it's at. Okay. The next one is MC stop. If anything during the motion you want to stop it, this function block allows you to do that. It's called MC stop. And then this function blocks is basically the PLC open function block, move absolute. So if you want to move to a certain distance from 0, you would use the move absolute function block. And then last but not least, this motion controls function block set position basically allow me, let's say I want to jog to a certain location and I want to set that to be 0. So I can do that using the set position function block. So that's basically a basic just overview how the function block works. So let me go online and show you how it works. So I'm going to connect it here to go online. All right. So first and foremost, the motor itself is already, it's not locked. So let me do that. Let me go and turn this off. Actually, let me see if there's, make sure I have no error here. I'm going to reset it anyway, just in case. Okay, no error. Everything's good there. Look, come out is, you notice that I can move the motor freely, right? So let's say this is where I want to turn on a servo. I'm going to enable it. And let me see my watch windows here. Okay. I'm going to look at my status right now. And here's my status. All right. So I'm going to enable the servo. Okay. And the servo is on. I cannot even move it. And you see it say ready here. It was false before, but now it's true. So now the motor is engaged and I'm ready to go. So at this point, I already set up the velocity to be 500 units per second, and the jog acceleration I set to be 10,000. The jog decel I set up to be 10,000 as well. So at this point, if I turn on the jog button, the motor will start moving. So let's do that. Here we go. It's moving, right? At 500 units per second. I'm going to change that. Let's say I increase it 10 times more. So 5,000. Hit enter. I'm going to turn it off. As soon as I turn it back on, you see this is going to move a lot faster now. There you go. Okay? Now, if I want to stop it, I can go down here, go to my MC stop, right? Right here, and turn on this bit here. And now it's stopped. All right? So, that's how it works. I'm going to move slowly. So I'm going to change move velocity to, let's say, 500. Okay? And move slowly. Okay? And my goal is when this, reaching this point here, I'm going to stop it. So I'm going to get ready on my stop here. And as soon as it hits here, I'm going to turn it off. Actually, I did too quick. So let me run it again. Move relative. Actually, I did move relative, which tell it to go 10,000 units. And 10,000 units means one revolution. That's why it goes back there. Okay? If I do it again, it will move one revolution and it will stop there. Watch this again. Okay, see that? And also, I know where that is by looking at the actual position. There are some other units before also, remember we were jogging, right? And then we tell it to move 2 revolution. That's why it's at this point. If I tell it to go another 10,000 units, then this will become 128,792. So let's see if it does that, okay? So it just finished it, and sure it is, 128,792, like I said, okay? But let's say I want to move this to a certain position, I want that to be 0. So how do I do that? So let me jog. Okay, I'm going to jog. I'm going to let it finish 1 rev. I want to stop when it's here, so let me get my stop ready, which is here. As soon as this marker gets up here, I'm going to turn this bit on. Here we go. So I want that to be 0, right? So right now, it's at this position, but I want this to be 0. So how do I do that? I go to set position. I set the position to be 0. As soon as I turn on this bit, this will be 0. The actual position. Here we go. Let me turn this off. Well, there you go. So now it's 0. Now you notice, look at my, I'm going to try to turn it. You see how I'm moving. If I let my hand go, it will correct itself. So it has a absolute encoder, barrierless absolute encoder. It will correct itself, even though it's stepper, but because it has that. So that's how it works with the barrierless absolute encoder. So now, if I want to move 1 revolution from there, I can go up to the move relative and execute this. Okay, see how it went there? Let's say I want to increase the speed to, let's say, 30,000. Okay, let's do it again. You will see it move a little bit faster now. Okay, actually I can increase this as well. Let me increase it to 50,000. I'm going to do this decel as well. Make this to be 50,000 as well. Okay, and let's execute it. There you go. See, a lot faster now. Okay, so we know that we move 4 times. Okay, now I'm going to tell it to go 0. So I can use the move absolute, which is here. I'm going to tell it to go to 0. The distance is 0. So what we'll do is we'll return back for revolution where that is, right? Because it's at 0 right now. Let's make sure 0. Okay, I'm going to execute it now. There you go. So that's how the move absolute function block works. Let's say I want to go 20,000, which is 2 rev. You will notice that because I'm moving absolute, even when I'm here, it will move 1 rev and another rev. Here we go. Voila. So that's how you set up the Oriental Motor EtherCAT drive model AZD-KED, and also the motor itself, which is AZM668KH, to work with the PLC that has the EtherCAT master. Thanks for watching, and please call the number below if you have any questions.